Okay, welcome to the fourth set of exercises in advanced programming. Today I will try to solve one of the lazy streams exercises. And again, I will not start from the first exercises because I think the firsts are fairly easy and similar to what we had before. But I'd rather pick on one of these things that are a bit more challenging, which might mean that this video will get a little bit longer. I'm thinking to do this exercise number 8 here, or its very first point, the map function. So what we are asked to do is to implement the following functions, including designing their types: map, filter, append, flat map, using fold right. So we're supposed to use fold, and I'll just work on map. The append method should be this last sentence only affects the append, so that's number 3. We're not going to look at that in this video. I'm just going to look at number 1, and I think we also have a test case here. The complication in this exercise is that there is no automated test in the test suite because there is no types and the test suite would not compile, and I always want the test suites to compile. So you have to add a test suite, and here is one suggestion what that could be, or what could we test on. Okay, so let's get started. I have already cloned the directory, and let me go to the directory number 40 and let me open my editor, as usual the wrong one. Okay, and maybe I want to keep this somewhat side by side, or maybe not. Let's see. Yep. Maybe I'll be switching like that this time. Okay, so all the exercises this week are in a file called stream.sca, just to confuse you once in a while. And this is the exercise number 8. And as the exercise has announced, there is no type for this defined. I'll zoom in so that you can see better. So when there is no types and I am starting the exercise sort of on a very open mark, I don't find it very useful to run tests. The first thing I would like to run is to make sure to run the compiler in parallel to make sure that things compile whenever I build them. So terminal spt, getting in for it to boot. Almost there. Okie doke. And now I'll just start the compiler in a loop. I'm mostly interested in the type checker at that stage. Okay. Okay, so maybe it's useful to remember a little bit about the context here. I am of course rusty. I was teaching about option today, so I forgot everything about streams. And I'm just looking around this file. What we have here, we have fold right implemented. That's good news. We will need that to solve the exercise. And all these things are implemented as methods on the trait stream, which is covariant, and it already defines a type parameter A. So the parameter, the type of this stream in the body is already defined. Okay, so we're in exercise 8, and we operate on an object this, but we still need to map. We need to know what to map. We need some function that maps A's to B's. And I suppose this whole thing will produce a stream of B's. Now type A is bound by the trait, as we have seen above, but the type B is not bound, so it becomes a type parameter. At that point I save, and let's see whether this compiles. It's still good. So let's continue. How that mapping will work? Well, actually, at that point where I have a type signature, what I would prefer is to write a test for this whole thing, so that test first development works very well in this course. So I'm gonna search for a spec file on this one, and I don't have one for exercise 8, but let's create it. I'm gonna create it in the bottom of the file just for the convenience of running this in a video, so that the result is always in the end. Other exercises are not solved in this file, so we'll get a red wall, and it's going to be hard to find what we are working on. So let's take the test case from the exercise. So let's look what we had here. It's a good question whether this exercise is solved, but this is not going to work. Naturals, yeah, natural. I cannot use this test case because I haven't solved the earlier exercises, and I want you to solve them yourself. So I have to invent a new test case. Well, what can we do? It's actually difficult to design a test case without all these good functions in here, but I'm pretty sure I can invent something. Okay, I have a constructor, so maybe I will test on finite streams, and I'll just map a function that always returns 42, and that should give me a stream of 42, 42, 42. That's a little boring. The test case not from the exercise. And maybe we'll cram 2 of them in here, just in case you always did something with this stream. Well, just to rule out that we have a constant map, let's also check that incrementation works. Okay, so the stream mapping 1 to 3 with a constant function 42 should give us a stream of 42s, and mapping this finite stream of with an incrementer should give us a stream 2, 3, 4. And let's say it's always useful to try an empty stream that nothing crashes. Let's try to do that. Okay, so I have now written 3 test cases here, and they have not been compiled because the compiler only compiles. I would have to run another command, test compile, to compile the test cases, but I'm just gonna write test, and oh, it's a very good thing that this happened, and this compiles the tests as well, and then they run the tests, and the compilation failed as far as I can see for an invalid reason. As mentioned many times, Scala type inference is undecidable, so that's partly why so many interesting things are possible in this language. So the compiler once in a while fails, even though our program appears to be correct, and we might be dealing with this case here. What happens is the compiler infers the smallest type for the stream, which is a stream of nothing. The empty stream is a stream of nothing, if you remember, and then we try to map its element with a +1 incremented, and that fails because nothing cannot be incremented. So I need to cast it up. My first attempt would be just to make it a stream of integers, and this seems to be going through. Yep. So what has happened here is that I have, well, this constructor returns a stream of nothing, but a stream of nothing is a stream of integers because streams are covariant. So this now, so now the compiler knows it should be dealing, the map should be dealing with a stream of integers, and the integers can be incremented, so that anonymous function now type checks, and it still gives us an empty stream. Okie doke. So we have now some tests. The test of course fails because I have not implemented the the map function. So let's go there again and let's try to work on this. So I'm looking at the stream this, and that stream has two constructors. Either it's empty or it's cons of some head and some tail. And as you see, I like to maintain my programs syntactically correct. So whenever I don't want to finish some expression, I just put three question mark in, and the test suite still doesn't finish. I hope we get it to work without all these other things. Oh, and now I forgot. Of course, this is completely wrong because we're not supposed to use pattern matching. Error. So this is a very realistic unscripted situation. We're supposed to use fold right. And I am very rusty on the order of arguments for fold right because that's slightly different in most functional programming languages. So what I'm gonna do, I'm gonna just paste it here in a comment so I get things right. So when I am folding to make a map, I'm going to be constructing a stream, and my seed element will be an empty stream. So far so good. And then I will be using a function, an anonymous function that takes a pair AB of type A, B, where B is passed by name. Right, and that function is going to produce something. Let me sort this out later. So I'll just use fold right. So this all seems worth trying. So let's see whether it compiles. No, it doesn't. Still anonymous functions cannot be by name. That's interesting. Because we actually want, okay, that's an interesting case. We don't want a function that takes a pair. This notation means we want a function that takes two arguments, perhaps. Let me try that. So that might actually work. Let's see. Of course, this was supposed to be small b. And another syntactic hack in Scala. If we want to decompose a function like that, the case is needed. But this doesn't seem to be what the whole thing needs. So let me read the error message a bit more slowly. So let's take a different approach to this one. As you see, I have not tried to solve it before recording. Let's call this function helper. And let's define the helper here. So let's think what it's supposed to do. Well, it's a function that takes the tail list and consists on top of it the head that has been already transformed with f, right? So I'm going to have a helper function, and I'll give it, it's going to receive an A, and it's going to receive a B by name, and it will return a B because that's what this type says here. Okay, and what it has to do is to convert the head. So A is now the head of the list. That's how hold right works. So I want to convert A, right? And I wanna conset to the tail, and my tail is what I received as a B from the helper, and that's it. Actually, that looks like my function. And this one, maybe it's that. So what happens now? Okay. That's interesting. So what is my fold right? The type of B, that what I'm constructing with my fold right is a stream of B's, right? Let's help the thing. So this should not be a B, but it should be a stream of B's. Maybe the other solution would have worked as well, but now I am having an A and a stream, so stream of B's, and yeah, this looks reasonable now. Why this doesn't compile? There is another little error here. This type is supposed to be a stream of B's. Yep. Okay, so this now compiles, but strangely enough it fails tests. These tests failing might be unfortunately because we have not solved other exercises, and it's not wise to start from exercise 8. But let's see. Yeah, so unfortunately I cannot show you the tests passing. I would need to solve exercise 7. The test should crashes on exercise 7. So you're not able to see the results for exercise 8, which is way more below. So if I was solving these exercises in order, this would have been sorted out. Sorry for that. So you have to believe me that it works. And this was an entirely unscripted, and I'm actually pretty proud it went so fast, an attempt to solve the stream exercise after a year of not solving any and not using the stream library. So that's pretty good, I think. I hope you know how to get that. If you are doing them in order, your test should be passing now. Then you can move to filter, write types, create a test, write an implementation, make sure that the test passes, etc., etc. I can't be entirely sure that this solution is correct because I have not tested it, but if it's not correct, I'm pretty sure you will let me know. So otherwise, good luck with the rest of the set.